For our ELG project, we decided to do an EMG controlled prosthetic hand or claw. It works by detecting differences in your muscle contractions through these very high-tech sensors. They're pennies connected to copper leads. Those signals are fed into an amplifying circuit, which is under this Arduino, which filters and amplifies your signal, which separates the desired frequency, which is the frequency that your muscles operate on. This is then fed into our Arduino circuit, which is right here, and it compares this to a set value. So if it's relaxed, if a relaxed signal is sent through, the Arduino doesn't send a signal to our servo motor. So if a tense signal is sent to our Arduino here, it'll tell the servo motor to rotate a certain amount of degrees. In this case, I think we have it at 90, and then hold there, so it'll hold an object or whatever you want. And it's controlled using these two gears. One's driven and one's just linked in, so it'll move in the same speed but opposite direction as the driven gear, which operates the claw arms and able to grab things.
Hi, my name is Troy Angleo, and I'm here to talk to you about signal conditioning for the myoelectric prosthetic claw. So our prosthetic claw's signal conditioning was broken down into three main components. The first of these components were the sensors. The sensors were composed of pennies attached to shielded copper wires, which were affixed to the skin using a saline solution. We had three sensors, one placed on the elbow acting as ground, one on the bulk of the forearm muscle, and one on the wrist. Now these fed a signal, or the potential difference caused by the muscle contraction, into our instrumentation amplifier, the second component. Our instrumentation amplifier was custom built using LM741 op-amps and a series of resistors as listed in the specifications to produce a voltage gain of about 1000. This allowed us to take the 1 millivolt signal we received from the forearms and amplify it to 1 volt. We then took this amplified signal and fed it into a wide bandpass filter. The wide bandpass filter is composed of a high and low pass filter in such a way that it allowed us to signal only above 140 and below 30 Hz. Within the range of 30 to 140 Hz is the medically accepted signal range for forearm contractions. The rest is noise. We then took this filtered and amplified signal and fed it into our Arduino microcontroller for further processing and rectifying.
So right now I'm going to talk to you about the Arduino and the signal processing. So right here, this is the Arduino board that we use to control our prosthetic arm. So what happens is an AC signal is sent to the Arduino through the circuit, and that AC signal is converted into a digital signal which goes through the multiplexer, and what happens is the code tells the Arduino to move the servo when a signal of more than 3 volts is hit. So if a signal of more than 3 volts is hit, then the Arduino will tell the servo to move, which moves the hand. And when there is no signal being sent, the servo will go back to its original position, which is back to 0.